Okay, so now that we've learned so many different methods, we can now look at which method should I use. So obviously it matters. So here's a little flow chart that can help you decide. And it says, are you finding the probability of a single event? And if the answer is yes, you move that way. If the answer is no, you move down. If it's yes, you move up. If it's down, you move to the bottom. So are the outcomes equally likely? How about the top? If yes, then it's NE, the number of the event divided by the number of S, the total sample space. And if it's no, then is it possible to get empirical data like testing? And so if it is, then yes, a frequency of E and the number of trials. If no, then you use subjective probability, which is like when a sportscaster predicts who's going to win the Super Bowl based on the coaches and players and such. If you answered no to the first question, is it a single probability? Then we move to the bottom and do the events involve or an and, or at least. If it's or, then you move to or. And are they mutually exclusive? Obviously, there's two different formulas. If you move to and, then it's two different formulas. And if you move to at least, then you're using the complement. So we've talked about all of these in the past. So let's move on. You're on Deal or No Deal and are presented with 26 cases that contain amounts ranging from 1 penny to $1 million. You must choose the initial case to set aside. The amounts that are randomly distributed among suitcases prior to the game are shown in the table. What is the probability that you pick a case worth at least $100,000? So there are clearly 7 of those cases that are worth $100,000 or more, and there are 26 total. So 7 out of 26. This is a very simple problem. Hopefully you guys can figure stuff like that out without too much thought. You probably don't even need that flow chart for that. According to a Harris poll, 14% of American adults have 1 or more tattoos, 50% have pierced ears, and 65 of those with 1 or more tattoos have pierced ears. What is the probability of randomly selecting an American adult that has 1 or more tattoos and pierced ears? So clearly this is an and statement and on the flow chart, and so P of E is equal to 50. P of E, given that T has happened, is 0.65, and they're not independent. So now we use the general multiplication rule, and you have 0.14 times 0.65, and you get 0.091, so 9% chance that happens. Okay. Then, are you making a sequence of choices? This is for your counting methods. Are the number of choices at each stage independent? Then, if yes, then you can do the multiplication rule. If no, then you can use a tree diagram. Are the choices making a sequence of choices? Are you making a sequence of choices? No. Does the order matter? Yes. Permutation. No. Combination. And then there's just a bunch of different branches, obviously, and we'll go through those right now. So the Hazelwood City Council consists of 5 men and 4 women. Since it's a council, how many different subcommittees can be formed that consist of 3 men and 2 women? So we'll do this on the boxes. So we're going to choose from the men and of the women. And so on this one it says consists of 5 men, 4 women. How many different? 3 men, 2 women. So obviously order doesn't matter. We have 5 choose 3 and 4 choose 2. And I don't know what 5 choose 3 is. I'm going to use the calculator just to be quick. So we're multiplying these together because that will make one committee. 5 choose 3. 10 and 4 choose 2. 4 and 6. So there are 60 ways. So 10 and 6. Okay. So that one is taken care of. Obviously, does order matter? The answer was no. The Daytona 500 has 43 drivers, first, second, and third and fourth. Okay, so does order matter? Yes. So then we're going to use boxes for this one. So we're going to go 1, first, second, third, fourth, and it said there were how many drivers? There are 43. So 43 first places, 42 second, 41, and 40. Multiply all that out together. 43 times 42 times 40. It's not 40. There are a lot of ways. Okay, so there are that many ways. So 2,961,840. Sorry, we're not looking at this one. We're looking at this one. And that is that. So, guys, really just, you have to make sure you know if order matters or not. If it does, then permutation. If it doesn't, then combination. If there's repetition of distinct items, if indistinct items, then you use your division formula with your permutations and so on and so forth. Just practice this. Make sure you're doing it on MyMathLab, and I think you guys will do fine. Thank you guys for watching.